Yeah, first of all, this is called the Ringberg formula. Apparently, this person just commented and said that was the formula name. Thank you for that. I did not. I mean, probably should have wrote that name on here. That would have been more, economically viable. But who cares right now? Actually, no. I mean, I could do that. Actually, I do care. Maybe I should make this into insert new drawing. Do this. Formula for frequency. We can make this bigger. Size. The formula frequency is that. We can make this smaller. Oh, that's like a little tricky to put in here, but we can. It's the frequency formula. And if I save it, does it turn out good? Yep. There you go. Perfect. So we're done with that section for probably forever. Um, we can move on to morality, but as soon as I tried to talk about morality, I needed to talk about having God's number and all of the shenanigans that every time I look at this, I always forget what the hell I'm doing. But you have to look at the periodic table to understand anything. So when you look at the periodic table, they don't really give you what it means, but we can go back here. I'm probably going to have to put this Jamboard and erase everything and explain what's going to happen. But so if you go to periodic table like this, you see this 1.0008. You have no idea what that means. Well, 1.0, there's a 0.03 because there's a special isotopes. Um, Isotopes that have like maybe one more neutron or like three more neutrons. I don't know. I believe hydrogen has like four different or five different variants, but they're super. No, they have two variants. Hydrogen that has one um, neutron, and then two neutron and three neutron can only be done by a lab. So there's four variants, right? Because there's one without any neutrons at all. Um, Okay, so yeah, I believe that's correct. But the third neutron can only been done by a lab for a fraction of a second or something like that, which is why it's not tangible in real life, so it's invalid. But the basic idea is the amount of what did they call it again? The amount of average, the average amount, the average is one proton basically. So it's like that's kind of how it goes. Um, the 6.221 times 10 to the 23 tells you the amount of atoms in there. So if you think about it, that multiplied by 1.008 can tell you the amount of atoms, right? If there's one hydrogen and you multiply that, it gives you the amount of hydrogen in there. Does that make any sense? I'm not sure if it does. So, okay. So let's look at, I don't know, chlorine. Chlorine has, where's chlorine? I don't remember where chlorine can be. Shit. I should know this. 35.45 grams. You can think of it as that times moles, right? Grams times moles would equal 35.45. So a sample of it. Yeah, that doesn't really work out well, does it? All right. Anyway, I might be wrong, but what I remember from chemistry honors, shit, oh my god, I just got reminded I need to put my chemistry honor professor, a teacher in high school. I don't think I put it in here. Damn it, what was his name again? What was her name again? Well, it looks like I'm going back to my transcript to figure out who the hell my chemistry high school teacher was. Dutton, I believe. Miss Dutton. So I'm gonna have to search that online and go to high school teachers and figure that out. I'm gonna look at my yearbook. Oh, that's gonna be a pain in the ass to figure that out. Because I'll tell you right now, my professor, my high school professor, my college professor, I barely learned any chemistry from her. I did learn some things, but it was more definition based than anything else. I already, yeah, it's kind of weird. Um, yeah, so I'm hesitating because I'm trying to remember how to do moles conversion, which I totally forgot how to do, which is embarrassing right now. I'm hesitating because I totally forgot. Yeah, I should know it, but yeah, fuck me. It's like one of the more basic things I learned. Ah, man. So if I was given, let's just say 5.88 to 5 point whatever, I don't know. Give me a random number of atoms, right? If I was to get 5.62 moles, actually that won't tell you anything. Five atoms of something, you could divide that by the Avogadro's number to get moles. And moles, with that mole, you can multiply by, because you got the amount of atoms here, and you divide it by that to get moles, you can multiply that by one of the periodic table to get the atomic in grams. Right, yeah, right, yeah, that I remember, right? So, so mass of the sample equals amount in moles times mass per moles or something like that. So I it's been a long time. I think that's called molar mass or something like that. Yeah, and then if you want to get the n, which is the amount of moles of certain something, you have to get the mass of something divided by the molar mass. Yes. So the equation would be, yeah. So it would be the atoms equal mass of the sample divided by the molar mass, or mass per mole. Actually, is it molar mass? I think it's mass per mole or something. Yeah. So molar mass is denoted by what again? I forget. So we can say mass. We can do something. The amount of moles. I can just do this. Copy that. I'm not going to that, and then do this equal divided by, I believe it was the amount in moles. No, amount, no, mass of sample. So let's just say that's 50 grams. And then there's the molar mass here. So if we look in the periodic table over here, I think I gave out what the molar mass here is. If I didn't, I'm a dumbass. Oh, I did do something here. A number of months. Um, I did a looping definition. Huh. That is not the way you should do it. That's a bad definition I gave. Let's look over here. Okay. So, for example, if we're given a fluoride, which is a diatomic atom, so it always goes in F2, so it times it by 2. Or if you get oxygen, which is 16, which is 32, if I gave you 26 grams, you have to divide it by 32, which equals, if I was, oh, why am I pressing this? Where's my calculator? Oh shit, I don't have a calculator on me. Well, you can do it in hand. 36 divided by 32, that's 1 no, 1.2 something, I believe. Let me check that. Okay, I can use my phone calculator. 36 divided by 32, 1.125. Yeah, that's the amount of moles. And then if you want to get the amount of atoms, you multiply that by Avogadro's number, which is 6.0002. Uh, you know what? What am I saying? What am I not typing? Yeah. So mass of the sample. Okay, so that's true. Then we can just, we'll go to Jamboard here and make one. So we can set background. I think I like this color best. So we can do this. I don't know. So give a random digit. I don't know. So let me get my pen out. So let's just get, I don't know, it's usually done by grams. So let's do, I have 1.37 kilograms, which because I did I need to do it grams, I need to multiply this by 1,000, which is 1.370 grams of, let's just say, what item do I want? Let's call it, I don't know, potassium. 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 I don't think there will ever be that much potassium. Um, okay, so that's the sample size. I want the moles, so I have to divide that by going to the periodic table and going to mass per mole, which is done by going here, going here, going to the periodic table of contents or whatever what you call it. I don't really give a crap what you call it. Um, oh my god. Actually, I think it's the one I'm looking for. Let's go to the periodic table and go past it 39.10. I know this is not a dynamics, so we can get potassium by itself. Actually, let me double check that. Can you get potassium by yourself? Let me email. Um, let me. Can you get potassium? I don't even get potassium um, by itself in real life. In real life. Never found itself. Damn it! It's bounded by something else. You know what? Change that plan and change to oxygen because at least I know what the oxygen will be turned into. Oxygen. Well, we know that's O2. O2. So I know that's one oxygen. One O is 16. Let's just say grams per mole per uh, uh, 16 grams divided by mole. So this O2 must have 32 grams per mole. So what does that really mean? So it means for every 32 grams, there is one mole. Because if there's 32 grams of oxygen somewhere, that is equivalent to 1 mole of something, which is kind of like unit length definition. If you don't know, we in physics we do a lot of this equals p. That's the is it density that we're looking for? No. When we get oh my god, what did I use that for? Actually, I totally forgot. I'm blinking here. I'm dumb. It's gonna take 5 years to search something up here. Um, I made it, so I know where it is. Ah, here it is. So when we're doing, not this one, mass, DM. When we're doing DM, you kind of get the feel of density on how it works. What I mean to say by that is that it's a little bit, how do you say it? Confusing for a lot of confusing because what does unit length mean? It means that for whatever unit, one of this unit of this, so by having a dx, it literally says if you do an integral of that because it's one, you're getting all of this because it's a uniform. So uniform means that if you get all of this and you do this, you get it out of here as dm. You're doing the same thing as the derivative of the m, integral of the m, because they're all same density, same and then the length, if you go at a unit base length, adding it all up will be the same thing as the m because density is uniform. And it only works because uniform, which means it's a one unit addition. Did that make sense? Probably not. Uh, well, you're gonna as a as I need to know that because that's kind of what I have to do for my MAE 105 class, which I don't understand at all. I'm just slugging through it really. So this is N oxygen 2. So uh, wait a second. N oxygen 2. Yeah, yeah. Because I'm yeah oxygen 2 uh, is the right definition. So I have 1370 grams. Oop, wrong. I don't like how it slides, but it's not gonna hurt me. So it's 32. So I have in reality, what you have to write is 32. Um, excuse me. Um, G, if I'm not correct. The professor never docked me points for fucking this up. But moles, right? So we're supposed to say O2 over here, and then -1 over here, uh, equal whatever we find here, which is not hard. You just do CC on your calculator, or C to clear your calculator, divided by, I have to use my left hand, 42.8125 moles of mole of O2. Now, if you want the O, well, you just have to do. If you want if you want just oxygen, you just have to times that by two because that's what happens. So, or you can do 85 um, or times by two and get 85.625 moles of oxygen. Either way, it's fine. There, I just it doesn't matter what one way you do it or the other way you do it. It doesn't really matter. I use a diatomic molecule because it's so much easier than using a. But now with the individual moles I have encountered, I already know this much moles are in here. I can multiply by Na, Avogadro's number, that equals what? I don't know. Which let me rewrite this as 8.65 25. Just so you know, to be fair, that kilograms to gram conversion is iffy at best because three-digit numbers are usually not so accurate with how they weigh it. You because of how the thing works, it's very hard to weigh. To transfer 1.37 kilograms into grams and not say that's accurate. So, you know, I this is a very gonna be a inaccurate answer, but is it 23 or 22? I don't remember actually. It's 23. Good. Um, with that said, I need to do this equal, which I really don't want to do, but let me see if I have it in my history. So yes, I have it in my history. Um, yeah, so I want to get the amount of moles here, so I have to times that by 2, like I said, and then multiply by 6.022 times by the 10 to the, let me square this, and then go back here. What is this, 23? So I get 5.15. Significant figures makes me do 3 digits, which technically should give me 6 over here. But usually the professor doesn't care about the last digit as long as it's close because of a rounding mistake that happens with how they round it. So they would be okay with 5.564 just because of how your calculators were like because sometimes they put 85 and they round it there for some reason when you write it down because who cares, uh, at least that's my experience with college. So but you have to say atoms of oxygen. They care a lot about your units over here. They don't care too much about how you get it. I mean, as long as you get the right answer. If you get the wrong answer, then obviously they care. And they care. But 16. So, all right. To be fair, this was a if e conversion because I wanted to show a conversion here. But usually the questions will be in grams already, and it will be like it won't be as big as the one I gave you. Just because it's kind of pointless. Why the hell would you give your students 1,370? Like it just doesn't add up, dude. Like, I mean, I wouldn't give anything. I mean, I'm a student, so I can't say anything. But unless your teacher is I don't know, want to torture you for some real reason with a calculator, I don't see any reason why anyone would give that kind of question. Anyways, Control V here. Um, that's fine. I'll add something here to make this more palatable. I don't know what I'll add.